Okay, YouTube, on this particular stone, you guys can see that I have that oil slick. I've used all kinds of abrasives to try to remove this oil slick, and it does no good. Still remains there. I've used all types of various grits without any luck. And so you guys can see the table facet. Once I get it into focus here, just get that, that light. You guys can see that it's not being removed. So this is obviously a Charles and Colvard. And so they do put some type of surface coating on this material, whether to change the color or increase the fire. I don't know yet, but you guys can see that clearly once I change magnifications here. Okay, 30x magnifier. You guys can see that. Right there. Forever brilliant. Yeah, it comes up. I can see it. I can read it. Forever brilliant. Yeah, you guys can zoom up or pause it or whatever. You guys can see that clearly says forever brilliant. So it's got good fire. It's got an extra rainbow sheen to it because of the table facet and the crowns and star facets. And it is on the crowns and the stars. You guys can see that sheen. But as we look through that crown, you guys can quickly spot that doubling. Okay, so I'm gonna adjust the camera here. Yeah, it's good. And then I'm gonna place this stone right there, and you guys can clearly see that surface compared to all these stones. These are all Moissanite. This is 7mm, and all these are 7.5. So what we're going to do now is we are going to pause this video, and we're going to see if this coating has any effect on electrical conductivity. Okay, so now we're going to turn this on. It's ready. Remove the cap. Make sure our fingers are touching the. Give it a good cleaning here. Alright, now we're going to see if this 7mm. Let's get this in the frame. The 7mm. I'm going to have to put the stones on their table and then pick them up. Okay. So we're gonna squarely hit the table facets. We're gonna see if this red light turns on here. So that's flashing. So this picks up. We need to use the tweezers. Place it on the table so you guys get a measurement. I guess you guys can see that. No results on the table facet. If we go to the pavilion, no results. So this one's not picking up. I just touched the prong here. So this doesn't look like it's picking up any So that's not picking up on any electrical conductivity. So what we're gonna do is use this tester. This is the best one because this tells you if it's double refractive or not. And instantly we can see that double refraction. So this is Moissanite, but it doesn't, there's the GRA inscription on there. Let me zoom up just here. You guys can clearly see that doubling. So it's a non-conductive Moissanite. Now we're gonna do a second stone here. Okay. See that doubling on there? Quickly identify it. You know it's Moissanite. The GRA laser inscription, you guys can kind of see it. Okay, let's turn this back on. Let's see if we can get a reading. Let's zoom out just a little bit. Yeah. And again, we get nothing. You guys can see. Let's put into frame. Nothing. No results. No results. So this is, again, this isn't conductive. So another stone, not conductive. Zoom on just a little bit. These are the two non-conductive stones. That was conductivity. And then we're going to check this stone here. I'm also going to, most likely I'm going to try to figure out how to remove that oil slick on that stone, and I'm going to see if the conductivity changed. But we can see these are brand new stones. Right out the gate, we see that doubling, so we know this is a Moissanite. See if we can see the inscription. Let's zoom up here. Polished girdle. See that laser inscription right there? See, spot that doubling right there. All right, we're gonna zoom up just a hair. Okay. So this one was conductive. It stays on there. So this is a electrically conductive Moissanite. Let's see if it's on its pavilion. Oh yeah. So this is strong conductivity. So we'll put this one right there. So that's conductive. Let's see if this one is. Okay, this one was conductive too. So we're 2 for 2 no-go and 3 conductive. So we're 2 for 5 on the stones that are not conductive, but this one has conductivity on the pavilion. Doesn't really have it there. Let's see. A little bit there. Just a hair there. But on that table, pretty strong. Okay. So now for the Charles and Colvard. Notice that's the one with the oil slick. You can really see that oil slick right now. Zoom up just a little bit. You can see that doubling. And there's the laser inscription, forever brilliant. Okay, let's see if this is electrically conductive here. Touch that prong there, you saw. So it does not appear, where I'm touching it on the coating, it's not indicating that it's electrically conductive. Scratching every bit of it, making sure I'm not hitting that prong. So this Charles and Colvard is not conductive. It's conductive on the pavilion. Yeah, it is conductive on the pavilion, just not on the where that oil slick is out. So that oil slick doesn't indicate it's Moissanite, but on the pavilion there's no coating and it indicating that it's Moissanite. So it's pretty interesting right there. You guys can see it in real time. When I touch the pavilion, I get that electrical conductivity reading. But when I touch that table where that coating is at, nothing happens. So that's interesting right there. And now we're going to see the results under UV transmission. So here's the stones. This stone, the Charles and Colvard, this stone was not conductive on the table. These stones were not conductive at all. It was conductive on the pavilion. These stones were not conductive, or these stones were electrically conductive, and so was this stone, the smaller 7mm stone. So let's take a better view of these. Let's see if we can kind of get a color assessment of these stones. Once we kind of tilt them here, and you guys can see which one is more colorless. So they're all advertised as being colorless, but that's not the case, because all of them have a bit of color to them. I'll put this right here, kind of weigh this down. Okay, here we go. So these are pretty white compared to this stone. So this has a little bit more warmth. You guys can see that. So this Charles and Colvard kind of sticks out like a sore thumb. You guys can see it's noticeably has a warmer hue compared to these modern Chinese Moissanite. This one's probably the closest to colorless. Oh, the one on the end here. So if I remove this, there's no background. Zoom up a hair. So obviously this is this stone right here. These got a little bit more color, but it's this one right here that's going to be the has the least amount of color to it. Okay, so now we have the full spectrum light LED. Now we're going to be turning on the short wave or long wave UV light. We see that one of the stones vibrantly fluoresces red,